Hey, science kids, how's it going? This is Mr. McComb. Hey, we're starting a new topic today as we get into our science time. Hopefully, yesterday you completed the Unit 5 review that wrapped us up on ecosystems. That was always a lot of fun to learn about, even when we weren't together. And you turned in your project that relates to Hatchet and all the work you did in Hatchet. And how we can relate the Canadian ecosystems and connect together our learning. Those are always fun to do, those kind of projects that bring together more than just one topic, more than just one subject in class. So hopefully you turn those in. Again, I'm looking forward to seeing all the results from that and all the neat things you came up with there. We are going to start a new unit today, and hopefully you've read a little bit and read through and now watching my video. And this is about motion, and we're going to talk about kind of physical science and the way things move and the way we can measure motion and the way things move and some of the things that cause movement and the different forces and things like that. Basically, our first lesson is just called What is Motion? And there's a couple of things in here I want to point out, kind of basic stuff. We're going to go through just a couple of the pages that you would have read already today, okay? So this first page that we get to 240 and 241 is talking about basically the kinds of motion or the ways we know that motion's happening. Like, well, when you hear the word motion, you probably think movement, right? So moving things, moving objects are in motion. That's kind of simple stuff. But we do have a definition for a couple things here. They talk about position is the location of an object in relation to a nearby object or place. So basically, position is just where you are. How can we tell where we are and what can we refer to? For me right now, you see this behind me, the wall. That might be how we can tell, well, Mr. McComb is in front of a wall, and that's me relating to another nearby object or place. So my position right now is I'm in front of my computer, I'm in front of the wall, I'm kind of in between those two things. And then the way we can tell motion happens, motion is a change in position. Again, simple stuff, right? When we talk about things being in motion, they're moving. How do we know the position changes? Well, we relate it to the things behind it. So if I'm over here, I move over this way, my position is changing. The way you know I'm moving across the screen is because the wall behind me stays still. You can see that motion happening. So we've got motion occurring there. Simple, simple stuff. What I do want to cover on this page also is the three types of motion. They talk about these in here, and again, it's not all listed out, but it's just sort of in the examples. But we're going to talk about three types of motion, and I'm actually going to use the playground as an example for where we can think of how these things might happen. So one type of motion they discuss and point out here is straight line motion, okay? Oh, sorry, 1 second. Let's figure out what I'm doing here. Okay, here we go. Straight line motion is one kind of motion. So they kind of mention that down here. And it says the girl flips down the balance beam. She moved in a straight line, okay? Straight line motion is kind of like the simplest form, but it's also sometimes the rarest because for things to go in a perfectly straight line is not quite so common. So I'm actually going to move that over here for three types. The most common kind is curved motion. Here it says the boy's body moves in a curved path around the bars. They're using a gymnastics example. Curved means kind of, in this case, circular or just going around, not in a straight line. This girl might move in a straight line across the bar. This boy is spinning, and it's in a circular curved motion as we go there. So curve means kind of bending. Again, that's kind of more common because it's pretty much any motion that's not straight is going to be and curved in some way. So if you turn a corner as you're walking down the hallway or whatever, as we're running around on the playground and things like that. And then the last one is back and forth motion. Now this is kind of like curved motion, but it's actually another example of motion that we'll want to look at here. So we'll do back and forth, okay? So we're going to do just a few examples of these, again, thinking about like if we were on a playground. So again, they use this gymnastics example, and when we're playing sports like basketball, football, whatever, baseball, all those kind of sports involve motion, and we're going to do a little activity with sports in motion later on this time. So if we're thinking about ways we can go in a straight line, maybe on the playground, how might that be? Maybe running a straight line would be one. Font's a little smaller. A little slower there. We could run in a straight line. Oh, Mr. McComb, you're taking forever. We could run in a straight line. All right, what else could we do? Maybe could run in a straight line. We could go down a slide that's straight. We could roll a ball straight. So again, I'm kind of having to say in a straight line because a lot of times if we throw a ball or kick a ball or roll a ball, it's not going to go straight. So curve could be all kinds. Again, curved are easy ones to do, where we might have examples like playing tag. You're not going to run a straight line. You're going to turn left. You're going to turn right. That's curved motion. Playing tag, throwing a ball up in the air, and it comes back down, right? So that could be another one. When it comes back down. That could be like an example where maybe what we're doing is throwing that ball up in the air. It goes up, and then eventually it comes back down. That curved motion, that's again, that if we were to draw a pathway that ball follows, and it ends up over here when we throw it to our friend, it's not going to be in a straight line, right? It's hard to do. So that curved motion happens there. Again, curved motion just means anything that's basically not straight. Now, where we can have back and forth motion, back and forth basically refers one direction and back the other way. Okay, so right now I'm kind of like when I use my arm, I might move it back and forth when I wave hello. That's sort of an example there. Another thing we could say is if we're maybe like on a swing set, let's say we're doing that. Swings are a great example there. If we do a swing set, we're swinging on the swing set, that would be going back and forth. Here's our swing, and it's going back and forth. Back goes this direction. Kind of swinging back and forth there. Okay, great. I'm not doing a great job drawing. Sorry, not always the best at that on the computer. Swinging back and forth. We could also have like an up and down kind of motion too. If we have, let's say, I'll switch colors here to spice it up a little bit. Let's go purple. If we have a teeter-totter or a seesaw, think about which way would that be? What would that motion be like? Well, that's going to be kind of an up and down motion, right? So we have a seesaw, people kind of on top and bottom of it. That would be motion that's taking place that's more of an up and down pattern, okay? But we go back and forth. The seesaw kind of go back and forth motion, okay? These are just the types of motion. Again, most often we're going to have curved motion, like when we're just walking around, unless we're walking in a perfectly straight line, we're usually going to be curving around. If you're playing in your yard, you're doing curved motion. So these three types, straight line, curved, and then back and forth, those are three kinds of motion, okay? So again, simple stuff. I just got to think about these specifically when we talk about different examples, okay? Let's see if we can go to another part. Now, the other parts of the book get into, is this the page I want? Yeah, it is. Talking about speed. Now, speed calculation is going to tie in a lot with what we're doing in math with dividing. We can calculate the speed, measure the motion by talking about how fast things are going and using some calculations for that, okay? So we can do a little equation. The big thing I want to point out from here, speed tells you how the position of an object changes during a certain amount of time. That basically just tells you how fast things are going, right? And then we have this word velocity, which we'll talk about in our next video a little bit more closely, but velocity is the speed of an object in a particular direction. Now, a lot of times speed and velocity are considered sort of synonyms, but if I talk about the velocity of an object, it's going to tell me not only how fast it's going, but what direction it's going in, okay? So it might be a speed of, say, a car on a highway, 70 miles per hour, but if I tell the velocity of that object, it would be 70 miles per hour north, if we're traveling north, or 70 miles per hour east or west or up or down. It depends. But velocity tells us the speed and the direction, so it adds in that one little extra piece of information, okay? Now, the way we calculate speed is to use this equation. I'm going to kind of put up here, I've got over here. This is a big one, okay, for us. We're going to use this equation. It's basically, we take the information we have, and we can find the speed by taking the distance something travels divided by the time that it takes to travel. Okay, so when I say miles per hour for a car, that means that we go a certain number of miles every hour. So our distance is miles and our time is hours. So we might have different types of distances. We might talk about inches or feet or meters or miles. We might have different amounts of time as well, like minutes, seconds, hours, whatever it might be. But we can talk about all those. Another common one is feet per second. Now, we usually wouldn't describe a car in that way, but we talk about the speed of like maybe throwing a baseball. Well, I guess baseball is kind of miles per hour too, isn't it? But if we talk about how fast something travels, like smaller objects, we could talk about how many feet per second. In this case, if we look at our example here, we're going to talk about a turtle, a cat, and a rabbit, and how fast they are going in meters and seconds. So the distances they use here are meters, and the time, it says each of them is going for 10 seconds, okay? So we're going to calculate some speed with these guys, and we're going to kind of do the math piece right here real quick to finish this up. So it says, what's the speed of the rabbit during the race? Now, if we look at the rabbit, it tells us the rabbit goes 100 meters. That would be our distance, okay? Our distance is going to be 100 meters, and our time is going to be 10 seconds for everybody, okay? So let's do that. We're going to talk about going 100 meters. That's way too big. Going 100 meters, there we go, that's a little better. 100 meters in 10 seconds. And this is going to help us know kind of what our speed would be. So to find this speed, we would say, okay, 100 divided by 10 would tell me the speed. It's a math problem, the distance divided by time. So 100 divided by 10 would, of course, be 10, right? So we're going to go ahead and tell our speed is going to be 10. And since we're doing meters in seconds, we're going to say that speed is, fill in here, 10 meters per second. So it's just a basic division problem, okay? 10 meters per second. So again, it always depends. We're not going to say miles per hour because it's not miles and hours, it's meters and seconds. So it says that's what we're going to use here. So what is the speed of the turtle during the race? Now this one kind of gets us into some decimals work because we have a slow turtle, much slower than the rabbit. This turtle's distance the turtle goes is 5 meters. So we're going to put in a 5 here. For our distance. And then the time, again, is still 10 seconds. So we're going to do 5. Again, distance, 5, divided by time, 10. Well, gee, what would that be? Well, hey, let's think about what we can do with that. We know what we can do with that. That's like a decimals problem, right? So if we have our decimal point here, 5 divided by 10 is like moving one decimal point back. So we'd have 0 and 5/10 would be that speed, okay? So we're going to do that now. So the speed here, again, this would be 0 and 5/10 would be what that answer would give us. And again, we're just using our math skills there, okay? So that's kind of some stuff we can do with that. Let me go to here to fill in, make it a little smaller. You could say 0 and 5/10 meters per second. That kind of makes sense, right? Slow turtle, not going to go very fast at all. Now the last part is about where we have, if we know what the speed is or how far it would go in a number of seconds, it says a chicken joins the race and runs at 4 meters per second. So in this case, we're actually being told that our speed is 4 meters per second. Okay, so probably didn't think you're going to be doing so much math today in science, but sometimes that's the way it goes. If we know the speed is 4, let's fill in what we know. 4 equals the distance is what we're going to find out where the chicken's going to be, and it's still going to do that 10 seconds. So again, they're all doing 10 seconds. So if we think it's something divided by 10 is going to equal 4, we got to think backwards a little bit. If I have a problem where I'm dividing by 10 and I end up at 4, what would be the number I would have to have here to fill in my answer there? What would be the number that if I divide it by 10, it equals 4, which would meet the speed that I want to have? Well, let's think. Again, if we just think of our basic division facts, something divided by 10 that equals 4, that would have to be 40, right? So 40 divided by 10 equals 4, which means that this chicken is going to go 40 meters. So that would be here, and at 4 meters per second, 40 meters would take 10 seconds. So it would go to this 40 mark, okay? So we can take our chicken, or if you want to draw your chicken, I'm just going to kind of grab one of these chickies and put them up here. on the 40 meters per second, or the 40 meters mark. Okay, so that's going to be there. And that is how we can do it. Okay, so this is just a quick look at calculating speed as a way of measuring motion. We are used to speed and we're used to knowing what motion means, but now we're kind of putting all that together. Okay, I'm going to go ahead and stop us here for the day. Again, thanks for reading, thanks for watching, thanks for listening. Hopefully this was a little bit helpful. We'll hit it more tomorrow, talking more about calculating speed. Thanks, guys. Have a great rest of the day.